Hello, grade 5. Our science lesson for this week is about changes to Earth's surface. And throughout this lesson, we are going to talk about two important processes, which are weathering and erosion. And we are going to learn how do weathering and erosion shape Earth's surface. We are going to talk about the Earth and its composition, and we are going to see how do movements of the crust change Earth. So, we are going to start our lesson with the first process, which is weathering. When you think of rocks, words like hard and solid may come to mind. You may think that rocks can't ever break, but that's not true. Rocks can be cracked and crushed by wind and rain. Let's look at the first picture on the left. The roots of this tree broke apart the rock. In the second picture, we can see that when it rains, water can get into the cracks of rocks. When water freezes, it expands. This widens the cracks. When water freezes again, it pushes the cracks in the rocks even wider. When this happens many times, the rock breaks apart. The process of rock breaking apart is called weathering. We have to know that many different things can cause weathering. Gravity can cause rocks to fall down a cliff and break rocks below. Flowing water can also cause rocks to tumble and scrape against rocks in the riverbed. Living things can also cause weathering. A tree's roots can grow in a small crack in a rock. Animals may dig up rocks, causing the rocks to be exposed to wind and rain. Chemicals in water and rain that flow through and around rocks can also cause weathering. These chemicals can combine with the rock and change it. Now, let us move to the second process, which is erosion. Don't we all think that rocks just sit around in the sun all day? But no, rocks can move. And let's find out how. Rocks can move. We have to know that weathering is the beginning of a series of changes that often occur to rocks on Earth's surface. The same wind and water that can cause weathering also can carry the broken bits of rock away. The process of moving weathered rock from one place to another is called erosion. Let's look at these pictures. So first, the erosion of rock is caused by many different natural processes. Moving water is one of the most common causes of erosion. The fast-moving water in this stream can shift or move large rocks near the top of the mountain. Together with gravity, water can cause the rocks to move downhill. The water pulls the larger pieces of weathered rock along the river's bottom. So as the water slows down, it has less energy. It cannot move the largest rocks and pebbles. These are left behind as the water moves on. We have to know that the dropping of weathered rock by wind or moving water is known as deposition. As the water in a river continues to slow down, more bits of weathered rock are dropped. This happens because slow-moving water has less energy than fast-moving water. So slow-moving water can carry only very small pieces of rock, such as sand and silt. These bits of rock are called sediment. Finally, when rivers reach the ocean, they slow down even more. As they slow down, much of the remaining sediment in the water is dropped. Over time, the sediment piles up near the mouth of the river. It forms a landform called a delta. Now, we are going to talk about wind. We know that the wind is just moving air that can pick up and move sand and other sediment. By definition, a landform is a natural land shape or feature. Weathering and erosion by wind change landforms. Wind can carry particles of sediment from place to place. So, when the wind deposits a lot of sand in one area, sand dunes form. Sand dunes are often found near sandy beaches, but dunes also form far from oceans. We have to know that the shape of sand dune constantly changes. Wind sweeps up one side of a dune and lifts sand from its surface. Now, blowing sediment can also cause changes to other landforms. Particles carried by wind collide with exposed rock and cause weathering. Exposed rock can slowly erode, leaving interesting shapes. In this picture, we can see the dunes of the Namib Desert. Now, we are going to talk about the Earth, and we are going to discover what do we have inside the Earth. So, Earth's crust is its rocky outer layer. The crust is hard and made of many minerals. Earth's crust is thinnest under the oceans and thickest under mountains. Now, we have to know that the layer below Earth's crust is the mantle. The mantle is the thickest layer, making up about 2/3 of Earth's mass. It contains some liquid rock, but is mostly solid. At the center of Earth is a core made of metal. We have to know that we have the inner core and the outer core. The inner core is solid iron and nickel. The outer core is molten liquid metal. Now we are going to talk about plate tectonics. Earth's crust is the hard shell of rock, but we have to know that it is not one solid piece. Many pieces of crust, called plates, fit together like a jigsaw puzzle. The plates rest on Earth's mantle. We have to know that the motion of Earth's plates is very slow. The theory that Earth's crust is divided into plates that are always moving is called plate tectonics. Some plates contain mostly continental crust, others contain mostly oceanic crust. Many plates are made of a combination of the two. In this picture, we can see that Earth's crust is made up of large tectonic plates that are always moving. Now, we are going to talk about earthquakes. Movement of whole tectonic plates is very slow, but once in a while, a small piece of earth can shake enough to crumble buildings to the ground. A fault is a break in Earth's crust where rock on one side can move in relation to rock on the other side. As plates move, pressure builds up along the fault. When the pressure becomes too great, the rock on one side of the fault suddenly naps free and slides past the rock on the other side. This release of energy and shaking of the ground is called earthquake. Now, we have to know that the point inside Earth where an earthquake begins is called the focus. The energy from an earthquake travels away from the focus in waves. When the energy waves reach the surface, the ground shakes. And the point on Earth's surface directly above the focus is called the epicenter. Earthquake motion is most severe at the epicenter. We have to know that earthquakes can be dramatic and can cause great damage to built structures. Finally, we are going to talk about volcanoes. The liquid rock below Earth's crust is called magma. At boundaries, where plates are either moving toward each other, pulling away from each other, or at hotspots in the middle of plates, openings in the crust can occur. By definition, a volcano is an opening that allows magma to reach Earth's surface. Lava is the molten rock that erupts from the volcano along with ash and hot gases. Now, these pictures show that we have different types of volcanoes. Non-explosive lava flows form shield volcanoes. Broad sheets of lava steadily build up to form the wide, low shape of a warrior's shield. Explosive eruptions form cinder cone volcanoes. Lava explodes into the air and quickly hardens. The fragments fall and collect to form the volcano's steep slope. Alternating types of eruptions form composite volcanoes. Explosive eruptions produce the steeper slope, and liquid lava flows cement the fragments in place. That's it for this week, grade 5. Thank you for your attention.